Hello. We started the second part of this book where we discussed the laboratory procedures. The first episode is about the definitive cast and dyes. We know that they are primarily made of gypsum, whether in its variation in different types, but the most important criteria that the dye must have no bubbles and be preventable from abrasion, also capable of enduring the high temperatures of the other laboratory procedures. The sectioning of the dye is important that we can able to see the finish line properly and do the appropriate margin design for the pontex and the abutments. There are several methods of the dividing that we will see now. Also, we will discuss the improvements on the material and the recent advantage about the digital scan. Here, a dowel pins are inserted under each so that each individual stone die can be removed from the cast, or the teeth can be sectioned from the die and trimmed to a root shape. This is the defect-free occlusal surfaces that are essential for the precise articulation that must be maintained in the pour of the die. Although gypsum is considered the main material that is used for the dye, there is the introduction of the resins that is incorporated with the gypsum, so it strengthens it and lowers its expansion. A material name is resin rock that is popular for cast of implant restoration to increase the abrasion resistance of the die stone. Polyurethane is also used, that is stable in its dimension, although it is more expensive and undergoes some shrinkage during the polymerization, but it can be compensated by slight adjustment in the other steps of the fabrication of the restoration, and we will know the details about this sentence in the chapters that are coming. Also, the polyether impression material has been used as a dye substance. One study has revealed that the combination between the this material 3M from the company 3M and with another one, which are polyether impression material, were good in doing the dye. As for the digital scan, it is the most advanced, and we can get so many high details from the scanning. Here we can see a comparison between a polyvinyl silicone impression that captures a high detail of surface detail, but when we got the optical scan, we can see that we got the detection of the changes in the elevation of the ink in the bill, and we can see the big difference between the two, that the details that we got from the digital scan cannot be achieved from the normal impression. Now we will discuss the different methods of adding the pins to the die. The first method is a two-pour method, where we the first pour is only maintained in the preparation side. Before it sets, we insert the dowels. Then after it's set, we get them out and trim and do the shaping. Then we reinsert them to the impression and do a pour on the whole impression. Then when it sets, we have an impression that has a sectioned teeth that the dowels are inserted in, with the base that has all the jaw of the patient. The different pores can be made from different stone material. These are the different shapes of the dowel pins. We will see the different systems of how we can do this thing. For the dowel insertion and the die trimming, the first one is the die lock system, which involves a specially segmented trays. We do a single pour technique, which means that we fill the trays with the die material. After the die stone has fully set, we insert the locking and the curved arms to the tray are removed. And now we remove the cast and we start the trimming based on the sections of the base. The reassemble in the appropriate position is done following this ring and the base. Another method is called the Dental Ventures of America model system. We align the impression on a fixture, and then we have clear plate that we mark the dowel pin position on it. After that, we drill the holes in the position that are marked. Then we insert the dowels in the base plate. The impression is poured and the stone is placed around the dowel pin. Then they are placed over the poured impression. When it sets, we remove the base plate and the cast is trimmed. Then it is sectioned. Another method is the Zacer model system. The impression is leveled and blocked out with silicone putty and positioned over a base plate. The pin locations are determined and the pinholes drilled in the base here. Then they are inserted into the base and the impression is poured. Then they are inverted into the stone. After they are separated and when it sets, it can be sectioned with the aid of a precision saw. The choice of a specific technique is determined by the technician's personal preference. All the available systems achieve clinically acceptable accuracy. In the two-pour technique, the impression material must be silicone, and the first pour is always the most accurate, so we make sure that it is specific for the preparation site. Now we will see the Pindex system, which is considered the most expensive of all the previous systems that we've seen because it requires special equipment. The basic idea is that after we have the poured cast, we identify the places of the pins that we want to insert them, and we use a special machine to make the precision drills in the base of the die, and the pins are coated with Vaseline to ensure the clean separation. Then we add a plastic sleeves to the dowels. Then we position the dye and do a pour that covers these dowels. After it sets, we start the sewing of it, including the base that we poured. Appropriate sewing is important, that the removal of the individual teeth is easy. We will see some recommendations about the pouring technique. It can be done manually or using these type of vibrators and materials and equipment. For example, this is the vacuum method, where they are saying that pouring the gypsum into the water prevents the bubble, and we get more accurate results that we put the water first. Here they weighted the powder and they weighted the water as well, which were pre-measured to get a powder to liquid ratio that is optimum in accordance to the manufacturer's recommended proportions. Then it is mixed using this type of device. Of course, it can be done manually if this type of device is not available. As for the pouring, they are saying that to avoid the trapping of air, start with a very small amount of stone and add them gradually, layer by layer. Especially the margin area is so important to be covered when pouring the mandible, and a blocking material, for example cotton or anything, to prevent this excess gypsum of the final mold. This is incorrect. This is the correct method. Another trick to preserve the location of the pin in the impression is to fix its position using the bobby pins and the sticky wax before we do the pour. Although disinfecting the impression may alter the dimension, but it is important to not send the impression technician before it is washed under running water, air dried, and disinfected. These are the different armamentarium for the sewing of the gypsum, whether it is the trimming discs or a sharp scalpel or a trimming burr, to get the optimum results. In the end of the chapter, they are discussing the digital application in the fixed prosthodontics. When we use a scanner to get a 3D image, it is converted to an STL file format, which is a method of dividing the object that is scanned to triangles, that each point of the triangle defines the place, the position, and shape of the material that is being scanned. So the collection of these triangles results in a model that represents the scanned object, so it can be manipulated using the CAD, which is the computer aided design programs, to get what is the computer aided manufacturing, the CAM result. So the file is imported to the software. We first create the base using the software, then outlining the tooth preparation margin. We determine the path of insertion. In this step, we can export the file to print it to a die, or we can proceed in the procedure of doing the design of the final restoration. The die is usually printed using resin materials with a 3D printer. So there are 3 ways to get the STL file. We can do a direct scan of the intraocular teeth, or we can do a scan for the impression, or we can do a scan for the cast. When we get the STL file, which is the triangulation of the object, it is manipulated using a canned program software to get a CAM, which is the manufacturing of the first file that we got. There is 2 digital manufacturing options. The first one is the additive or the subtractive. The additive is that we the manufacturing of the material stacked layer by layer to develop the final 3D object. The subtractive manufacturing, which is the more common, is by a power-driven machine tool that we remove a material from using this machine until the final object shape is achieved. So it's more about sculpting from a base material. Although these types of devices has an high initial expense, but it provides so much efficiency and preserves so much time in the manual methods that were used before. Final note that to get an accurate scan of the impression, we must have a finish line with 1 millimeter minimum of the tooth. That's it. Salam.